Okay, so we left off with y prime being equal to the above. So now let's go through and find y double prime of x as well. So the derivative of the first is going to be that's exactly the same function if you think about how exponentials and multiply constants work. So that's exactly the same. Times -2 sine. Actually, no, product rule. So hello, we need to make sure we go in, and that's going to be still the cosine of 2x. Let's think about what we're doing here. So again, that's cosine of 2x plus the first, which is c1 e to the x, plus 2c2 e to the x times derivative of the second, which is -2 sine of 2x. For the second term, the derivative of the first is going to be exactly the same. So -2 c1 e to the x plus c2 e to the x times the second plus the first, -2 c1 e to the x plus c2 e to the x times derivative of the second, 2 cosine of 2x. And then finally, the derivative of that lonely little term back there is going to be minus 9 e to the 3x. All right, so now it's time to impose those initial conditions. So first up, we've got y of 0. That must equal out to 4. So that says when we plug in 0 into y1, we're going to have a 0 in all those places. So the first term, substituting in 0, we're just going to follow along, is just going to be a c1 because e to the 0 and the cosine of 0 are both 1. So that's just a c1. The second term is gone because the sine of 0 is 0, so all of those terms are history. And then we're going to have a plus c3. And then the e to the 0 again is going to be -1. And again, that must equal out to 4. Now let's take a look at the y prime of 0 information. Plugging 0 into y prime is going to give us c1 plus 2c2. And again, that's equal to -1. So that's going to be, again, a c1 plus 2c2 times the cosine, which is 1. And then the second term is all multiplied times the sine. So that's going to be just a 0. And then -3 times e to the 0, which is 1. And that must equal out to a -1. And then finally, from the y double prime, we'll just use the big bloated form that we have here. That's going to be the c1 plus 2c2 again. Since that's times the cosine, it's going to stay there and be times 1. The second term is going to vanish because it's times the sine. The third term is going to vanish as well because it is times the sine. And then that last term is going to show up. So that's a -2 c1 plus c2. And don't forget there's a 2 with that derivative there. And then that's -9 times e to the 0. And that must equal out to the value of y double prime of 0, which is -5. So let's see what we actually have here. We have a c1 plus 0c2 plus c3. And if I bring that 1 over, that's equal to 5. Second equation says that c1 plus 2c2 plus 0c3 is equal to a 2 when I bring that -3 over by adding 3 to both sides. And then the last equation says that I've got a c1 here, and then I've got a -4c1 here. So that's going to be a -3c1. And then I've got a 2c2 and another 2c2. That's going to make a 4c2. So plus 4c2. And then there's no c3 term, but then we add 9 to both sides. -5 plus 9 makes 4. So that's equal to 4. So what we're left with is c1 plus c3 is equal to 5. c1 plus 2c2 is equal to 2. And then negative 3c1 plus 4c2 equals 4. So what we can actually do here is solve this by just a little bit of elimination to get our constants. We'll multiply the middle equation by 3 and then add it to the other equation below. So if we do that, we'll have a 3c1 plus 6c2 is equal to a 6. Adding them up, we get 10c2 is equal to 10, so c2 is 1. So if c1 plus 2c2 equals 2, then that says that c1 plus 2 equals 2. That forces c1 to be 0. And then if c1 plus c3 equals 5, then c3 must be 5. So next up, we'll put all this together to get our solution of our initial value problem.